Hey guys, so we're recording now. Let's get started. So let's go to bright space, I guess. 350. All right. So keep in mind we're getting towards the end of the semester. Thursday, no class because it's Thanksgiving break. Next week we'll have the last lecture on Tuesday. Um, and then on Thursday, if you guys want to demo just really quick what you have for your term project, just if you want me to give you a little bit of feedback before the presentation, you can do that. But it'll be kind of an open lab for whatever you got going or working on the term project. I haven't the last homework was the open SSL, right? That's already been given to you, the PDF. And I think I set that for the this info. Okay, and then don't forget presentations are the week before finals, and then we have the final exam. Yes, what's your question? Oh, the the week before finals. Yeah, the week before finals on that Tuesday and the Thursday. Yeah, so that's the plan for any questions for the semester. Today we have a standalone topic, if you will. So we can go to the table of contents. We're going to do some coding. Um, so we've covered pretty much everything, all the algorithms. If you remember, the last algorithm was Diffie-Hellman with elliptic curves, right? And we elaborated on that one. We talked about TLS and how it uses that. We talked about forward secrecy and why that's important, even though RSA hasn't been broken yet. It's the fear of somebody breaking it in the future. So already like the future is affecting the present, right? So kind of a strange time issue there, because it's possible that they never break it. I mean, that's it's not it's got some probability, right? But anyway, so people are adapting. So anyway, we covered everything really in like a cryptography one course. And so what we have left is applications. So today I'm going to talk about, so you can see we've covered this, we've covered PKI, and you're doing the lab. Today we're going to cover these two modules, and then next week on Tuesday, the last lecture, I will cover blockchain. So we'll go over some of those ideas. Keep in mind, there is a course in CIT on just blockchain. I think it runs in the summers, sometimes I believe, but you can ask. I think Professor Kim teaches it. I can't remember honestly, but there is a course on just blockchain. But I'll just give you a quick intro and tie it back to what you learned in class. Essentially, believe it or not, one of the biggest mechanisms in cryptography for all these applications is the hash function. So hashes, right? The thing that does integrity can be used for many other things. So we're going to talk about these two modules today. If you notice also, this ties back to, the principles of the pillars of information assurance that we've been talking about all semester. And we focus basically on confidentiality, right? Integrity, right? And authentication. But the pillars also have there's integrity, right? Sorry, there's availability. And so availability, we haven't really talked about um, this semester, but it still makes an appearance in the field of cryptography. So we know that denial of service attacks affect availability, right? So that's something that you probably learn in another course. So a DOS attack, denial of service, you send a whole bunch of packets, right, to hit a server, and the idea is to take down the server. So cryptography actually can do something about that. And so that's one of the things that we're going to talk about today. It might sound strange, but you can use cryptography as a defense mechanism against denial of service attacks. And this shows how versatile cryptography can be. In malware, you guys have been familiar with antivirus scanners for a long time, probably. And as it turns out, they were built on the principle of cryptography as well, hash functions, right? And so that's what we're going to focus on today. So we're going to do a lab assignment on malware. And so we're just going to talk about how this would work, sort of implement some ideas. So some students in the past have implemented ransomware from scratch from this lab for their term project. So that's something you could try to do. That would be obviously on the attack side, not on the defense side. All right, so let's go ahead and start with this one. So I'll start with malware. You can take a look at the slides here. I'm not going to go over them. This chart, essentially talks about what malware is, but it's software, right? So it's software that replicates itself and also tries to do something bad, right? So usually, like ransomware, for instance, would be an example. What does ransomware do? It'll try to replicate itself within the system, find some files that might be important, encrypt them, right? And then now your system, all your files are encrypted, you can't access them. And then usually the hackers or whatever, they're going to send you an email later on saying, pay me this much money and I will send you the key so that you can decrypt your files. Does that make sense? So that's usually what is called a ransomware attack, and that's using cryptography as an attack. Also for detecting antivirus, right? We can use cryptography. So there's various ways of building antivirus scanners, of course. There's static analysis and dynamic analysis. So today we'll focus on static analysis. Dynamic analysis would be when you actually have a computer virus on a computer in a sandbox environment, you run it. Imagine it's an executable file, a binary.exe, right? So if you double click on it, it's running. So in that scenario, that exe file is going to start doing things like accessing DLLs, making registry edits, maybe reading files, making connections to the internet. All of that, because it's a computer, is going to be logged. So that's why it's called dynamic, because you're logging all the actions that that computer virus is taking. Do you guys see that? So you'll have a file, a log file of everything it did. It read this DLL, it accessed this file, and made this registry edit, you know. And once you have that information about that computer virus, then you can start to scan it somehow, right? So that's dynamic analysis. Static analysis is what most antivirus have been based on for years, like the famous McAfee and all those, right? And essentially, what were they? They were just a database, right, of hash values. Do you guys see that? So what did we learn about hash functions? What was the definition of a hash function? It grabs variable length content to produce fixed length output, right? And what else did we learn? It would grab a file, generate the hash value. If we just change one bit of that file, the hash generated was completely different, right? Do you agree? So essentially then what people did is they would find computer viruses in other systems, a file, and they would say, okay, this file here is a computer virus, as is exactly. So then what you do is you take a hash of that, and that's it. Now you have that in a database of hashes. So whenever we would run in the past the antivirus scanner on your computer, what was it doing? It was running through all your files in your file system, taking that file, hashing it, and now it would compare that hash value to the database of hashes. And boom, if you had a match, computer virus detected. Do you guys see that? How great would it have been to have, 20 years ago, right? Knowing this, you could have created your own McAfee and made a fortune on such a simple concept, right? But anyway, yeah, so that's how it worked. Somebody just understood the power of hash functions. They spent their days looking for computer viruses, created a database of hashes, and then they sold that. Right. But that's the main mechanism. So that's, static analysis, dynamic analysis for computer virus detection. Does that make sense, guys? Any questions on that? Nope. All right. Yeah, so I just provided some information here. I have a paper, this one, polymorphic viruses, right? So what is a polymorphic virus? So a polymorphic virus is simply a static file that changes what does it do? It changes itself a little bit. So that's the way to escape detection, right? So whenever you make a copy of yourself, what are you going to do? Your original virus, and okay, I'm going to make a copy, but I'm going to just change something, some number that I'm generating randomly every time I copy myself, and that way I'm going to escape the antivirus scanner. Do you guys see that? And so it's very difficult, right? So actually, it seemed like a great solution initially to just create the hash of the file and then have the database. But every time the virus makes a copy of itself, it can just change a number. You guys know that just changing one thing changes the hash completely. And there's no way to trace it after that. That's why there is other approaches, like the dynamic behavior. This is called a polymorphic virus, and it's a fancy name for it changes one bit of itself. Got it? Makes sense? So you can read through this paper if you're interested in dynamic analysis. I mean, we don't have time for this one. And that one would not be cryptography either. All right. But yeah, and so today I'm just going to demo how to build one of these. We're going to build a computer virus based, in Python with no payload, obviously. And then just kind of elaborate how that would work and how you would create the hashes and everything. Got it? All right. So I think I have, yeah. Yeah, so how would you build an antivirus? And you don't have to do this as homework, but more of an exercise if you want to, building your own antivirus scanner or a ransomware tool, something like that. So I'll provide a script in Python actually, but it says here using the provided Perl script, implement an antivirus scanner in Python that does static analysis as discussed in class. So the static analysis means hash-based detection. All right, so we're going to go ahead and do this one. So I'm going to switch over to the virtual machine and just show you guys the behavior of a virus. And then we're just going to start thinking through it. Um, so let's go ahead and start the VM. All right. So this code is, of course, on the GitHub, on the cryptography GitHub. You can go there, and I think it's going to be under crypto applications. So you can look at it there. It's called the Cracklin virus. I don't know why, honestly, I don't. But that maybe somebody named Cracklin wrote it. I used to do this in Perl, but over the years I've switched it over to Python. So it's a more approachable, and it'll have all the elements of a computer virus. It's a file, it'll run, right? Sort of in an executable way. Obviously, permissions are important, right? So if you remember with old Windows, there was no user account, no permissions. You would just log in and do whatever, right? You were a super user essentially. So there is that requirement. Um, access control will not permit a virus to access other files. That's just how it works. You remember that from 372 probably. So, but yeah, this assumes at least the files under that account, though, will, you're logged in, presumably as C, doing your work in your office. Then all of a sudden you get an email, you click on it, you download, and then it's going to attack all your files that you have permissions on. Okay, let's go ahead and get started. So yeah, so we're going to start creating the computer virus. And then once it's built, we're going to try to infect some files in the Linux operating system. And then from there, we can talk about how to build an antivirus scanner. So we're logged in. Let's open up the terminal. I'm going to navigate to the desktop. Old 2025. All right, so let's create this is going to require several files. So let's just create a new folder. We're going to call it malware, crypto. We're going to CD into it. So we're here. All right, so we're going to need some files. I'm going to create files with two types of extensions. So some are going to be like TXT and others are going to be like maybe bin or something like that. And so we're just going to infect some files and not the other ones based on the extension to kind of create a smart computer virus. But the virus is going to be implemented in Python. All right. So let's go ahead and create it here. Nano, let's call it, Cranklin.py. All right. It's gonna have, a few functions. So I'm just gonna do that first. I'm gonna lay out like the structure of it. So I'm gonna do search. This function is gonna be for looking at what to attack in the file system, right? So how to move in the file system, etc. So I'm gonna provide a path for it. 1, 2, 3, 4, and I'm gonna do return. Then I'm going to do another function, infect. So define infect. This will take a list of files to infect. Okay. 1, 2, 3, 4. Return. And then we're going to do one function called payload just to indicate that there would be some payload, which is something bad that the computer virus is going to do, like ransomware or something like that, or maybe deleting the files, but this is not, it's going to be a benign payload, so we're not going to have anything. So I'm going to do define payload. Okay. And we'll come back to this one. This is where you would do like deleting or the ransomware. So 1, 2, 4, return. Okay. So that's essentially the structure. One thing we're going to need here, because we're dealing with the file system, is going to be the library for the OS. So we're going to do import OS. And we're going to do date time if we want to keep track of when to do the attack. So import date time. So these are essentially the two libraries that we're going to do. Okay. So once we have that, let's kind of go to create a main section, right, of how the virus would behave. And then we're going to start filling in the individual functions. And from there, we're going to talk about how this could be extended. right? So let's call this the main section. Okay, and we're going to have some path here. So the path is just going to be for Linux, our current working directory. Okay. Then we're going to do files to infect. So we want to figure out files to infect. And we're going to search which ones in the path given, which is the current working directory. Make sense? All right. And once this produces our files to attack, then we're going to pass those to the function infect. And this function is essentially just creating a copy of the virus, right? So it's going to, find other files and make those files. Let's say you have a PDF, right? So that would be kind of the idea. And it's going to try to replace it with the virus so that when you double click it, you infect and so on. All right. So we're going to do that. So infect is going to take files to infect. Files to infect. All right. And then of course, once that's done, it searches, it infects, then it's done, it's spread. And after that, it does the payload. So it would do some kind of an attack once it has spread. So this is where the payload would be, just like that. All right, so that's the overall structure. So now let's start focusing. Well, the first one would be search. We want to figure out what we want to do. But we're going to go in here into this function. 1, 2, 3, 4. Okay. And let's think it through. So yeah, so all we're going to do is look in our current working directory to see which files are there. That's the easiest thing to do initially. And then maybe say, okay, we're targeting a specific type of file. So let's go for those. All right. So we need to create a list, files to infect. Okay, so that's our list. 1, 2, 3, 4. Then we're going to use the OS library. So this is going to give us a list of files. So let's say files list. And we're going to print this out soon. Let me os dot list dir. So list directory. We pass the path. Okay. And this can give us, we can print it here. Let's just kind of stop here to see what this looks like. So files. Okay. So it's going to give us the files in the current working directory. Control X, Y, enter. All right. So now I'm going to go ahead and run it. I'm going to do Python. And you can see that the only file in this working directory is the Python script itself, right? So we're going to have to do something so that the virus doesn't attack itself, right? So that's probably not something it doesn't want to do, but we do need other files in here. So let's do just a couple of files. So I'm going to do nano. I'm going to say example one.txt. We're going to attack the txt files. So I'm going to say example one txt. Okay. I'm going to create another one. Example two.txt. And I'm going to write in here example two.txt. Something like that. Just some files assuming there's information in them. So now if I do ls-l, so I have two files that I will be infecting. I also want two files that I will skip just so that we can see the difference. So I'm going to give these the extension .foo. So I'm going to say temp1.foo. So temp1.foo. So Control X, Y, enter. And we're going to do one more. temp2.foo. So this is temp2.foo. All right, so now we should have 5 files in here. So we do, we have the cracklin.py, example1, example2, temp1, and temp2. Okay, these are just normal files. They're not executable files, right? But the virus is going to target every .txt file here, try to make a copy of itself into example1 and example2. It'll skip temp1, temp2, and itself, right? And then once example2 has been infected, then if somebody runs example2, it will go ahead and infect other files as well. So that's the virus spreading. So we're gonna, that's essentially how it is. But as you can see, the virus is this one. So in the something like McAfee and the static analysis, somebody would find that cracklin, say it's a virus, and essentially create a hash of that file, and that would be stored in a database. So that when you're running your scanner, if somebody downloads cracklin, at least originally you can find it, but it could spread and then it's harder to find. All right, so let's go ahead and continue. Or actually, let's run the script again. And you can see now it's got all the files, example1, temp1, temp2, example2, and cracklin. So we just need to add some logic to start targeting the .txt files. Okay? Any questions so far, guys? All right. So let's go ahead and do this. We're going to go back to the computer virus. Here we go. All right, so we are in search, so we can comment this out now. We know it works. 1, 2, 3, 4. All right, so now we need to iterate through this list. So I'm going to do for file in files list. Okay. So 1, 2, 3, 4, 1, 2, 3, 4. So now the first thing is we're going to grab every single file in file and we're going to split it on period so that we can look at the extension. So I'm going to create a variable called temp, and then I'm going to do file dot split on period. Okay, so we're going to split on period. And so the way that this works, we can print it out. I'm going to do print, and I'll show you. So I can do temp 0 because it's splitting in, on period is essentially creating an array of 2 values, right? Well, the first value is the name of the file, and the second value is the extension. So we're going to need temp1 actually, but we can view this. So let me do this. And you can see here it's printing the name without the extension. If I change that to 1, oops. If I change that to 1, it now prints the extension, which is what we want. So we want to just figure out which files to attack. Okay, so we're going to go ahead now. We can comment this out. We don't need to print this. All right. So now we're going to have an if statement in here. So we're going to say if temp1 equal the extension that we want to attack. So for instance, txt, and here you can add any kind of logic, right? So, I want to attack um, when Stuxnet many years, 10 years ago or something attacked, right? So I was looking for specific files related to a brand, Rockwell or something like that, that had to do with PLCs. So they were looking for something in particular to infect because that's what they wanted to target. All right, so here we're attacking txt files. So if the file, if the value temp1 in that file is txt, then we're going to add them to the list of files to attack. So 1, 2, 3, 4, and we're just going to say files to infect. It's a list, so we're going to do dot append. And what do we append in here? We're going to append file. And that's it. That's actually the whole function of files to infect. So return files uh, to infect. Make sense? Any questions? So that's it. So now when we run this, we'll have the two files, example1 and example2 in here, and nothing else. Even the .py file will not be in there. So the virus itself will not be changed. So in this attack, you would be able to find that file, cracklin.py, because you have the hash of it, supposedly. At least you would know that that was in your system, so it's likely other files may have been infected. All right, so let's scroll down. After search, we have files to infect, so we can print this out just to look at it. So we can do print files to infect. Okay, so files to infect. Okay. So let's run it. And you can see we've got example1 and example2.txt, which are the two targets that we have. Okay. So these also, if you're doing the ransomware, then we would use something like Python libraries, right, to encrypt those files, and we also need to delete them. So, essentially, that's the process. You would take the two files, have a key, encrypt them with the key, and then delete the original ones. All right, so this is done. So let's go back to the script. So the search function has been done. Now we need to look at the infect function, and then we can talk a little bit about the payload function. So let's go in here. So infect gets the files to infect. 1, 2, 3, 4. Okay, so let's put in a little message here. Print. We're going to say files received to infect. Just to confirm that we received it. Okay, 1, 2, 3, 4. So what else? All right, so now we need to infect the other files. So what we need to do is we need some mechanism where cranklin.py can grab itself. Do you guys see that? Like Cranklin needs to open itself as a file and extract the code and save it in a variable. All right, so that's what we're going to do next. It's probably like the hardest part to conceive, possibly. But a file can open itself in code. So let's look at that. So let's create a string variable. So let's call it virus string. So maybe we can use this variable to hold the code. So we could also just like grab all this code and put it in there, but this is like a more elegant solution, right? We write the script and then the script grabs itself. All right, so let's do first, let's just grab, let's see if we can grab, if the file can grab itself. So we would open, so we're used to opening files, right? So that's something in Python that's not a mystery. You guys have been doing that all semester. You open other files from a Python script, but here we need to open this file. All right, so how do we do that? Let's invoke the OS library. Let's do os dot path dot question absolute path. So abs path, and then underscore underscore file underscore underscore. So hopefully this will allow us to grab, this will allow this file to grab itself, if that makes sense. All right, so let's take a look at that. All right, so we can print out the contents of this line by line, but let me just try to see if I can print the whole thing. So print, I would print virus, right? So possibly like that. Okay, let's see if I was able to grab all this code into that variable. Let's try it. Clear. So it's in there, possibly, right? So IO text, IO wrapper, Franklin, UTF-8. Okay, so we need to find a way to print it out. So let's see how we can do that. So I'm going to try a for loop here. So I'm going to do for I, comma, line in enumerate virus. So I'm going to try to grab it line by line. 1, 2, 3, 4, and I'm going to print each line. Do you guys see that? So instead of printing the whole thing as I did before, now I'm going to try to print it line by line. All right, so let's try that. Control X, Y, enter. And there we go. It worked, right? Do you guys see that? So I was able, so the file, this virus was able to grab itself, grab the contents of itself, and now we know we have it all accessible. If you look at it, this is the entire computer virus. So now this is great because now it can copy, it can make copies of itself. So it can grab another file, such as example1.txt, and add the virus there. Grab example2.txt and put the virus there. So it's essentially just moving the software. And so we're creating this capability of replication. All right, so now we need to craft it a little bit more. So let's go back to it. Okay. And this behavior you can implement in many computer languages. So it's not just Python. So for those of you, when I've taught 450 in the past, I used to do this exact same thing in JavaScript. So just a few different properties where, and that can, could spread in the JavaScript environment over the web, right? So that's the difference. Infect websites, things like that. All right, so let's go ahead and go over here. So now instead of, we don't need to print it really. What we need to do is we need to add it to this variable virus string so that we have it available and then we can add it to the files that we're attacking. So I'm going to do 1, 2, 3, 4. So I'm just going to add it to this file like an accumulator. I'm going to do virus string equal virus string plus line. Remember that this virus string has been initialized as a string variable. Okay, and that should be it. So now, because we opened this file, right? The virus opened itself. We want to close it. So I'm going to do virus dot close. And now the connection is closed to the file, and we can print out virus string. Virus string, just like that, just to make sure it did work. I'll do Control X, Y, enter. And now I'm going to run it. And you can see I'm able to print out the code. Any questions? So essentially here I'm making just copied itself so far. So let's go back. All right. So what's the next step? The next step would be now we need to open the files that we want to infect, and we're going to attach virus string into those files. And then we need to change some permission things so that we can run them essentially. All right, so let's add this part of the code. We're going to do for fname in files to infect. Okay, so for fname in files to infect. So we're going to open each one individually. So I'm going to do 1, 2, 3, 4. So f equal open, and I'm going to open fname. The first one, example1.txt. Okay. Once I open it, I'm going to copy the contents of it into a variable, just in case, just to keep it. So I'm going to do f.read, right? So that essentially copies it, and then I'm going to close it. So I'm going to do f.close. Okay. So that's just to read the current contents of the file. Maybe there's like some important information, so you can see how this is also how you could potentially do the ransomware attack, right? So read in the contents of the file, encrypt that, and then delete the file. So if somebody wants to recover that information, they would need to decrypt that, okay? All right, so we closed it. Now we're going to reopen the file, but this time with the intention of copying the virus into it. So we need to write to it. So I'm going to say f equal open fname, comma, w, right? So this is going to be for writing to it. All right. And so now we can go ahead and write. So I'm going to do f.write. And what do we write? We're going to write the whole computer virus. We're going to say virus, right? Virus string, sorry. Virus string plus the original contents of the file, which are stored in temp. But in this case, because this is Python, so this part here is Python specific, we want to put a couple of comments in front of it so that that code is not, that whatever is stored in temp will not break the rest of the code. All right, so that's something that you would have to do specific to your programming language. So I'm going to do plus temp, just like that. Got it? Any questions? Okay, so you can see how now we're writing the virus to that file, and also its original content is there, but you have to kind of make sure that it's not going to run. So comment it out somehow. Once that's done, I'm going to close it up, and that should be it. So now I'm going to do f.close. Okay, and so let's take a look. So let's see if this works. This is doing quite a lot, like copying the content. It's not a full virus attack yet, but it's at least creating copies. So let's try it. Okay, clear. Let's take a look at the files in here, ls-l, right? So these are the files. If we open example one, that's the content of it, right? Example one txt. This needs to change now to include the contents of cranklin.py. So let's see if it works. Okay, so I probably need to get rid of that print. Let me in fact, I still have, yeah, this print I should have done. Okay, so I'm going to get rid of that. All right. Control X, Y. Okay, so it ran, no errors. So now let's take a look at the files. You can see example one and example two have become pretty big files. Now let's take a look at example 2.txt. You can see it now contains the computer virus. I did run it twice, so it might, the code is there twice, it seems. Right? Let me delete those two files and create new ones. So I'm going to remove example one. And example two. All right, so I'm going to create example three and example four. .txt. So this is going to be example three .txt. Control X. Okay, and I'm going to create example four. Example 4.txt. Okay. So now clear -L. So if we do cat of example 4, we can see it has this content, right? So what we want to do now is infect it. So I'm going to run the Cranklin virus. Okay. And now when I rerun cat, you can see it now contains the computer virus. All right. Any questions so far, guys? I noticed that there's an issue here. It seems to be putting the comment above so we need this comment in front of it. So I'll have to fix that somehow. But let's see if it runs, okay? So let's see if it breaks the code. I am putting it at the end, so hopefully it'll run the code and then maybe break at this point, but that's not an issue. All right, so one thing that needs to happen is currently the files have the virus, as you can see. So let's actually look at two things. So OS dash. So example 4 has the virus. Temp 1 should not have it, so let's check for that. So temp 1, see, it doesn't have it, right? So we only copied the virus to the example ones. But if I was to run example 3, example3.txt, nothing happens because, I can't run it, right? So let's look at the permissions. I have permission, but I need to make it executable so that it infects another file. So for instance, what I mean by this is I'm going to create an example 5 nano example dot or example 5 dot txt. And I'm going to say this is example 5.txt, right? If I try to run, we know that example 3 is currently has the code, the virus code, but if I run this one, it doesn't infect other files. That's something you want, right? If a virus is spreading, it means that it's here, but then you put it on this computer, and then if you run this one, not the original one, you infect the third one, right? And so that's what we want to achieve still. So the solution is to make it executable, essential. All right, and we may need um to have like the shebang at the top so that it knows where to run itself. So let's try that. So so example 5, there it is. Okay, if I run example 3, it's not going to, do anything. So we need to modify the Cranklin code to fix that. Nano. Okay, so let's go here and let's add a OS system command so that we can change the permissions. So let's do os.system, and we're going to run a terminal command. Chmod, if you guys remember from your 372, allows us to change the permissions. So I'm going to do u.x to make the file executable plus fname. So fname is the file in question. So essentially, once I copy the virus onto the file, then I'm going to make that file executable. And that way, when I run it, it should infect other files, such as that example 5 file. So let's try that. If it doesn't work, it's because I don't have the shebang in there. So Control X. Oh, my battery's low. Just give me a sec. All right. Well, let's do nano. So we added this command for the permissions. So now let's try it. Okay. Clear ls-l. So you can see, oh, I did run Cranklin, so example 5 is now infected. You can see also that I've changed the permission here so that it is executable. So essentially, we're very close to making, we've infected the files and we're getting very close to, if you run this, then it should infect another file. Okay, so the way to test that is to create another file, example 6.txt. Oops, I meant example 6. We're going to call this example 6.txt. Okay, Control X, Y, enter. So that file is currently not infected. Obviously, if I run Cranklin, it will infect it, but I want to infect it by running, let's say, example 4, right? That's my goal. So I would run it, the equivalent of double clicking on an exe file in Linux is just doing this on the terminal. So I would do example 4.txt. Okay. So it's not running, and I'm guessing it's because of the shebang. So we need to fix that. Yeah, so I don't think it worked. So let's do ls-l. Example 6 has not been infected, right? So how do we solve it? Well, the easiest fix would be to go to Cranklin itself. And you guys help me out. If you remember, what is the shebang for Python here? Do you guys remember what it is? No? Bin, right? Bin. Is it env Python? I think something like that. Bin env, yeah. So let's try that one. Control X, Y. Let's run Franklin. Did you figure it out? No, all right. Let me just run it. Let's do Python. We can look it up online, but Python. So that ran. So now 6 is infected. Let's create 7. Example 7.txt. Example 7.txt. All right. And now let's try running example 5, for instance. I'm going to do example 5.txt. Name error example 5. It's not because it did run it. Oh, yeah, that's the thing at the bottom, actually. All right, yeah, that's what I was saying, the comment. So now the way that we will know if it worked is if example 7 is now infected. Do you guys agree? So that's what we need to check. We need to see if this example 7 is turned green. It did. Do you see that? So it worked. So the little error we got is because if you remember, this was supposed to have 2 pound signs in front of it, and that's that part. It's not quite right, but the virus is working. Any questions, guys? Do you guys understand? So we created a computer virus, right? It's a self-propagating, as they call it, computer virus. So it grabs itself, saves it in a variable, chooses the files that is going to attack. Um, it copies the contents of the virus to those files, and not just that, but now those files can infect other other ones. So we can try it one more time. Let's create actually like two files. I'm gonna do nano example, not exa let's do example 10.txt. So this is going to be example 10.txt. And I'm going to create also example 11.txt. Control X, Y. All right. So as you can see, let's imagine initially we had Cranklin. Somehow Cranklin ran. It infected examples 3 to 7. And then another day, like a few days later, a new file, new files come in, 10 and 11. Somebody is doing their work. They don't realize that example 6 is actually infected. So they run example 6.txt. See, it runs this error, it's not affecting things. So now when I do ls dash examples 10 and 11 have now also been infected. Any questions? Do you guys see how it works? So yeah, so now you see the behavior of it. So now you can understand, the antivirus scanner, right? The problem is, well, finding Cranklin, if you have a hash value of it. So you guys have been doing this all semester. You would take a file, whether it's OpenSSL or PyCryptodome, you would take the file and hash it. And then so now you can imagine how you can build an antivirus scanner that just takes the files and calculates a hash, then uses that hash to compare it to some database. And then if there's a match, virus has been detected. Yeah, go ahead, please.
So since the code, somebody keeps like adding on to the that gonna be a problem right now? That makes sense.
Say that again.
So every time that you run Kraken, the other files are already affected.
Oh, that's right. Yeah. Well, let's grab the original one and see if it still infects another file, right? So do you see how that tells us? I think it'll still work. So what's the oldest one? Example 3, right? So let's create example 15. I'm going to create example 15.txt. Example 15.txt. And now I'm going to see this one is the one we want to infect. So now I'm going to run the oldest one, example 3, which we can look at it. Yeah, so let's run it with nano, I guess. See, it's got the code multiple times. So it might just run several times. Let's see. Let's try it. Okay, so we're going to run example 3 to see if we can infect example 15. Okay, it ran. No, it gave an error. What's the error here? Yeah. Yeah, it's so. And this is because, yeah, it's so yeah, that's a good point. The problem is I did not handle properly, um, what to do with the original text. That's the issue. So I need to figure that out. This is Cranklin.py. Yeah, so the problem is here in the code. I'm not handling this correctly. So see, this is the virus. It's like it's adding a new line character here. And that's really what I need to get rid of. So let me actually do this. There's a new line character, right? So what if I just do temp equal um, temp dot replace any new line character with nothing. Do you see that? So essentially, if there is a new line character in temp, I'm gonna get rid of it. Let's try that. So the place where we can see that probably in example 15. So if we look at example 15, yeah, so this I think is this. I've been adding this, I'm hitting enter and then this. So I think that may be the problem. So now, if this worked, once we infect example 15, this will have two pound signs in front of it, and then that would fix it, I think. So let's try it. Let's see. I need to run the original Cranklin. Click on. Okay, it finished. Clear. ls-l. So example 15 now, let's see. Let's do nano. Example 15.txt. All right, so there's the virus, and there it is. Yeah, so that fixed it. So now everything should be hopefully fixed. Um, yeah, maybe. Um, so let's see. Let's create another one. Let's do nano example 16.txt. Example 16.txt. Okay, and now I'm going to run just one of the other files, example 7, possibly. /l, so 16 is not infected. / example 7.txt. Okay, clear. So example 16 is now infected. Let's look at 15. Okay, so there's the code. And then, yeah, perfect, right? Do you guys see that? So it took the old whatever was in there and it just added a comment in front of it. So that actually solves it perfectly. Looks pretty good. All right, great. So it's working well. So we've completed the infection process. So now you have a self-replicating computer virus that will attack the files as you want it. You can see it's infecting files, and then when you run those files, they'll infect other files, and it's spreading like that. The last part of this is to look at the payload. So for those of you that want to do, let's say a ransomware attack, right? So you would do that in the payload section. So we'll just briefly discuss that one. But yeah, it would be, let's go back to the original Cranklin. So nano Franklin dot py, right? And here in payload, essentially, this is, we can add a comment. You can see that in the main, once it, it searches, then it completes infecting, and now it's in the payload stage. So this is where it would do the attack. So for instance, we can say here, we can add a comment, ransomware, or just deleting files, something bad. But in the context of cryptography, this is where once again you would search the files that you want, you would grab their contents, encrypt that, and once it's encrypted and you've generated new encrypted files, then you delete the original files. You can also set like a condition, an if statement, to act on a specific date, for instance. So you want to attack on a Tuesday at a specific time, so you can do if date time dot date time dot now dot day, right? And so, day, and then you can say equal. So what is today? Today is the 25th. So yeah, I want to do the attack on the 25th, for instance, that on that specific day. So you can set a command such as this, and then here, 1, 2, 3, 4, you do whatever you want. Delete files. We can try OS. I'm not going to do the encryption, but I'm going to do just like try to do a delete. So OS system. And then it would be RM, right, for remove. And then what do we remove? We remove, yeah, we would remove one of the example files. Yes. So you need to like select which file you want to delete. So perhaps, we can pass files to infect here to the payload and just grab the first one, right? So we can say files to infect, this just as an example, files to infect, and then we just remove the first one for whatever reason. So files to infect 1 or 0. Okay. Before we do that, actually, let me just print out which one that would be. So I'm gonna just do a print statement here. Today is the 25th, so that should work. Print, and then files to infect 0. So I just want to see which one is in there first so that we kind of know, because we do have a lot of them. So, oh yeah, and payload here down here needs to have files to infect as well. Okay, so let's try this one. All right, we need to run Cranklin. On Cranklin.py. Okay, so okay, example 16 seems to be the first one, right? So if I do ls-l, example 16 is still there. Run Cranklin again. Still gives me example 16. And it's still there. So now I'm going to change the code so that it actually does delete it. And so once I run it, example 16 should be gone. Does that make sense, guys? All right, so let me just go back to the code here. And we scroll down. Okay, so now it should get rid of it. Example 16 is still there. Okay, so now it's gone, correct? Example 16 is gone. Do you guys see that? So now the ransomware, what do you need to do? Just before you delete it, you need to grab example 16, read it, take the contents of it, encrypt it, generate an encrypted file, and and that's it, and then delete it. And so now you obviously don't leave the key there, right? Not that you guys would do this attack, but I'm just saying you wouldn't leave the key in there because then obviously they could decrypt it. And then the hackers or whatever are going to call you or send you an email and say, hey, we encrypted your files. If you want to recover your information, pay us this much in Bitcoin or whatever. And then once you pay them, they give you the key or a script, and then you recover your files. Got it, guys? Does this make sense how it works? Any questions? All right, so yeah, so I think that's we could keep going with this, obviously. To go to complete the ransomware idea, but like I was saying, you just really do it here. Like this step, because if you notice, you're actually running the terminal by running os.system. So to keep it simple, you could do something like os system OpenSSL here, right? So OpenSSL, right? And you just use the actual OpenSSL program to encrypt the file. But just before, you need to grab the contents of it. Or actually, you can encrypt the file directly, to be honest. You don't even need to grab the contents, right? But you need some kind of a key there and somehow get rid of it later. Any questions? All right, so that is malware and using you know as it and thinking about cryptography. We talked about ransomware and how that could be implemented as an attack. We also talked about how antivirus scanners work, which essentially, as I said, you would look at Cranklin, hash it, and then you would have that hash value in a database, and then you can do the comparison. Okay? All right, so I think it's almost 5:30, so I'll stay for a few minutes if you guys have questions about anything. But just a few reminders. Next week, it's the last lecture, so I'll go over blockchain and a few other things. And then we also have, if I remember correctly, on that Thursday, the scavenger, correct? So make sure you prepare for that. Yeah, and that's it. So I'll end the video here, and I'll stay for a few minutes if you guys have questions.